Hey everyone, welcome back to Age and Education channel. Today we shall continue with the chapter Acids, Bases and Salts. Right? So, in the last video we have dealt with some topics and the rest of the topics would be neutralization and about salts. Right? Neutralization and also about salts. First of all, we shall look into the concept called as neutralization. What is neutralization? It is a chemical reaction. What is it? It is a chemical reaction where an acid and a base react together to form salt plus water, right? So, it is a chemical reaction where an acid and a base react together to give us salt and water, and this salt can be a neutral salt or acidic salt or basic salt. Okay? What is it? It can be a neutral salt, an acidic salt or basic salt, right? So, how much acidic it would be depends upon the number of replaceable H atoms, right? Upon the replaceable H atoms, we can say that these are that much acidic. Okay. Now, how about a basic salt? In the basic salt, based upon the number of OH atoms, we can say that it is acidic of that amount. Okay. However, it may be, the salt always will be almost near to being neutral, right? It can be either neutral here or somewhere here, but extremities is you will not have to see more extremes. Okay, it will tend to be near to the neutral, right? I think I I'm up to the point, right? So, it always, any salt will always be tend to be neutral. It means that it can't be exactly neutral, but it will be near to the neutral. Okay, and this near can be to the acidic side or to the basic side. If it is to the acidic side, it will depend on the replaceable H atoms that can be replaceable, and if it is to the basic side, you can say that it will depend upon the number of OH atoms that can be considered to be replaceable, right? Okay. Now, it means that it is something of incomplete neutralization. In these two cases, you can find what? Incomplete neutralization. Because in complete neutralization, the salt that should be formed should be a total neutral one. But when you are finding acidic salt and basic salt, it means that there is incomplete neutralization here, right? So, now let us look into some characteristics of neutralization, right? So, characteristics of neutralization. What is this neutralization? Whenever you see this is not a new topic for you, because while you were studying about acids and bases, what have you seen? Acid, when it reacts with a base, or when base reacts with an acid, what you get is salt and water. This you all know, right? From the first video itself, this concept is clear to you. Now, we are just saying it by giving a name to it. Okay. So, acid plus base, when they combine together, they try to get neutralized and they become salt and water. If at all it is completely neutralized, then the salt will be neutral. But in case of incomplete neutralization, you will get either acidic salt or basic salt, right? So, what are the characteristics of neutralization? First thing is that it is always an exothermic reaction. What is it? Exothermic reaction. So, what is the meaning of exothermic? It means that this reaction tends to give heat, right? So, when this reaction takes place, it will always give out heat. Okay. The other characteristics would be, always this reaction will make the pH solution come near pH, like pH of the salt, to come near 7. Okay, pH will be near 7 but not exactly 7. When will you get exact 7? You will get exact 7 in case of neutral salt, but this is not the case always, right? So you won't get always a neutral salt. So it will be somewhere near 7, like if it is the like this, it will be near 7, okay, but it won't be too far away. And if it is a neutral salt, you will find that the pH of the salt is 7, right? And apart from that, you always know this, right? When acids and base react together, what you get is salt and water. So we also get water here, right? So apart from the salt, the reaction gives also water. Okay, these are the characteristics of neutralization. Now, why are we talking so much about neutralization? What is this all about? What are the applications? Right? Are you getting all this sort of questions in your brain? Yes, then it means that you are on the right track and you are concentrating on the class, right? Okay, now let us look into some of the applications of neutralization reaction. See, here, shall I continue here? Okay, few applications I will mention here, and later on I will continue to the next slide. Okay, first thing is for treatment of soil. What is the soil treatment? See, the soil can be like when you consider the soil to be too much acidic, right? When the soil is too much acidic, then what you have to do, like what usually people do is they add slaked lime. What is it? Slaked lime, so that acidic and base will combine together to neutralize the soil, right? So what is the slaked lime? Slaked lime is calcium hydroxide. What is it? Calcium hydroxide. Then how will we get this calcium hydroxide? All these are not important, okay, just for some information, okay. Don't just get worried with all this calcium hydroxide, calcium oxide and all this. What is important is its application. The neutralization application will go with regard to the soil treatment, wherein the acidic nature of the soil can be neutralized by using slaked lime. What is slaked lime called? Calcium hydroxide is called as slaked lime. Okay, so when calcium oxide, also called as quicklime, combines with water, what we get is calcium hydroxide. Okay, so you don't need to know all these details. Okay, if you want me to strike out, I will strike out, don't worry about it. What is important is already I have mentioned. Okay, now, and what are the other applications? We will get into the next slide. Here, it is also used in antacids, right? What are antacids? See, when you eat too much food or too much spicy things, you will feel like a burning sensation, right, in your stomach. This is called as acidity. You all know that what is the meaning of acidity, right? Because every one of us will eat something or the other from outside, and after continuously eating we will get this, right? So this acidity can be treated by using antacids, and these antacids are made using what? Using magnesium. What is it? Magnesium hydroxide. Okay, magnesium hydroxide, aluminium hydroxide, and what else? Calcium, sodium carbonate, sodium bicarbonate. Okay, all these can actually help to treat this acidity. Okay, these are all used in antacids. Okay, and this magnesium hydroxide, when when it is commercialized or when it can be used for consumption or can be used as a medicine, it is called as milk of magnesia, right? Milk of magnesia. Because yes, this is the active compound. Magnesium hydroxide will be the active compound in the antacid, but can it be taken directly? No, it has to be processed a bit, okay, so that it will become edible, or like it can be consumed by the people or taken by the people like a medicine. Okay, so it is called as milk of magnesia. Okay, why I am mentioning this especially is that in the exams you may not get this term magnesium hydroxide. They will say milk of magnesia, and you will get confused. What is this? We are not aware of this milk of magnesia, where it is used, how it is used, right? So in order to let go this confusion, what I am mentioning, both of these, like magnesium hydroxide is used as an antacid, and it is also called as, like when it is processed so that it can be used, or it can be used as a medicine by the people, then it is called as milk of magnesia. Okay. Now apart from this, where we can use this neutralization reaction in production of batteries, textiles, and to prevent tooth decay, and wherever, at many places you always tend to neutralize the acidic properties of the things, right? So in this manner the neutralization reaction is very much useful. Okay. Now we shall look into salts, right? So as I have mentioned earlier, the next topic would be salts. So about salts, you have already looked into the types of salts, right? What all I have mentioned, there will be neutral salts, or like normal salts, right, wherein everything got neutralized in a perfect manner, and there will be acidic salts and basic salts too. Okay. Now here what you have to see is that every salt has two parts, a metal part and a non-metal part. What is it? Every salt will have a metal part and non-metal part. So in the reaction, this metal part is, this characteristics of metal thing is obtained by the salts from the base, and the non-metal part is obtained from, yes, from the acids. Okay. So there is nothing to worry about anything here. It's just that we are just looking into salts in a greater detail. That's it. Okay. So salts always has a metal part and non-metal part, and the metal part comes from the base and the non-metal part comes from the acids, right? Now how about the preparation of salts? How are these salts prepared? Yes, you know that by this reaction, by the neutralization reaction, you get salt. But is that the only way to obtain salt? Aren't there any other ways? Yes, there are many other ways to prepare the salts. So we will look one after the other now, right? Okay. All right. Preparation of salts. The first thing we all know is what? Yes, we are so familiar, right? When acid and a base react together, what we get is a salt and water, right? Water. Now on I will write like this. Okay. Please understand that this is water. Okay. So acid plus base gives us salt plus water, and so this is the one of the ways that is used to prepare the salt. And what is the next thing? I am not giving any examples because I gave so many examples previously, right? When an acid reacts with a metal, what you get is again salt, and this time you get hydrogen. Okay. So I'll give you one reaction for this. Okay. Take any acid. Okay. So we will take hydrochloric acid and take any metal. What you get is a salt and hydrogen. Okay. So this is the reaction. Sorry, H2. Okay. When hydrochloric acid reacts with zinc, we get zinc chloride and hydrogen. Fine. So acid plus metal will also give us salt and hydrogen. What we want here is salt. Okay. Now again, what is the other way that you can obtain this one? When a metal and a non-metal react, then again we will get a salt. Okay. So one example of this would be what do you call, sodium and chlorine gives 2 molecules of sodium chloride. Okay. So this will be an example of metal and non-metal react together to give us salt. Okay. And the other way is when like any acid, when it reacts with some metal hydroxides or metal oxides, even then what you get will be salt and water, right. So when, what is it, metal oxide or hydroxide reacts with some diluted acid, okay, what you get will be again salt and water. Okay, you want some example for this too, right? See, one thing, it's not so important for you to like understand everything, but it is important that you understand the concepts, right? Like metal plus non-metal, metal when acid reacts with base, what you get, and all of these are so important, okay. And we are taking one example here so that you can better understand the overall concept, okay. So when an acid reacts with some metal oxide or hydroxide, then also what you get is salt and water. So what will be the example here? We will consider copper oxide, okay. Copper oxide when it reacts with sulfuric acid, okay. Copper oxide when it reacts with sulfuric acid, what you get is CuSO4, copper sulfate plus water, okay. So even with this you can get a salt, right. So here also we got a salt, here also we got a salt, okay. Now we are we will get into the uses of salt, okay. Here uses of salt, there are like many salts, and every salt has its own use, okay. We will look into some of the salts and their uses, okay. First thing is sodium chloride, NaCl, sodium chloride. What is this used for? Its application will be for cooking, de-icing, and it is also used as water softener, okay, and it is extensively used, water softener, sodium chloride. And next we will look into calcium carbonate. Is it calcium carbonate? Here what happens, where will we use this calcium carbonate? We will use it in building materials like in cement, right, and also we will use it in the preparation of glass, paints, and it is also used in the preparation of antacids, right. And apart from that we can also say that magnesium sulfate is a type of salt, right, and it is popularly called as Epsom salt. What is it? Epsom salt, and it is used as a laxative and is used in agriculture, okay. Also we all know about the bleaching powder, right. Bleaching powder, it is used for what? It is used for cleaning, right. Obvious, bleaching powder is used for cleaning, okay. And what else, did I forget anything? Okay, this is fine. And baking soda, you also know about the baking soda, it's very important, right. Baking soda is also a type of salt, and it is used for baking, and even it is used in some medicines, and it is also used for cleaning, right. So baking soda is also other type of salt. So we are done with this chapter, right. See, this took almost like 20 minutes. If I wanted to cover all of this in that video itself, then the video will reach more than half an hour, and I am sure that you won't sit for that long before the video, right. So that is the reason I made another video, freshly made, okay. We are done with this chapter, okay. Go through it again and again, because this is a bit complicated, like you are just being introduced to the world of chemistry, okay. Other thing is that if at all you feel like this video is useful, please consider liking the video and subscribing to the channel, right. Okay, thank you, see you, bye.